Hello everyone. Today we will solve some problem in Leetcode. So let's start. Our problem is key's largest element in an array. This is the 215th problem in Leetcode in medium level. He said that we have an integer array nums and the integer k and we need to what? We need to return the k's largest element in the array. And here we should note that this is the k's largest element in the sorted array, not in the distinct element. So here we may have some kind of duplicate numbers. However, we need to return in the sorted array. So here says that we have an array and we need to uh, return the second case largest element. So let's say here we may have some kind of one, two, three, and the four, and the five, and the six. So here, what we need to do, we need to return the second largest element, which is 5. Yeah, first one is 6, and the second one is 5. In the here, we need to return the 5. So here we have a lot of ways to solve this problem, but we need to solve it in the minimum time complexity time. Yeah. So here, by looking at this problem, we may assume that using using sorting, it would be easier to solve this problem. Yeah. We just need to. We will be use any kind of sorting algorithms, selection sort, quick sort, and other sorting algorithms, and just returns and the n minus case and minus case element in the array. Yeah. However, as we know, it would take some kind of more time complexity. Yeah. As we know that at the worst case, it's 2 n quadrat. However, in average case, it would be n log n time. However, we have some kind of other methods to solve this problem in more efficient way. So let's consider this. Uh, in here, we can use the priority queue, like heap priority queue, to solve this problem. And here we will heapify this array into heap, which would take n times. And as we know, we need to return the case element, so we will pop it every time. Yeah, and the popping in heap would take log n times. However, as we know, we need to pop it how many times? We need to pop it k times, which would be k. So here, the time complexity of solving this problem by using heap would be this formula, and uh, n plus k multiplied by log n, which is more efficient than solving it in n log n times. So let's solve this problem by drawing some pictures, and let's go.
So let's get into the drawing picture and explaining the algorithm. So here, as we can see, this is the max heap priority queue, data structure. And here, as we can see, the first largest element is 9, and the second largest element would be 8. Let's say we need to return the second largest element, which is 8, and how we can do it. As we said earlier, we have an array, and to heapify it, we will only get only n times, which would be to heapify it. Yeah, this is the n time. And secondly, what we need to do, we need to pop the k elements. Yeah, for example, if it's a 2, so we need to pop the largest element from our heap and put 8 into the 9. And popping is like deleting the element. So let's see how we can uh, delete our 9 in this data structure. Firstly, what we need to do? Firstly, we need to here delete 9 and put into the 9 the last element of our data structure of the heap, which would be 1, and here we will have 8. And as you can see here, as 9 is the last element, we can just not consider it and just delete it from the data structure. And here, 1 is not considered as the max heap, which is not in the max of our array. So here we use something that said shifting down. Yeah, we will shift down the element 1 to his place. Yeah, like we will swap firstly check if 8 is more than if 8 more than our 1. Yes, it's 1, and we will divide them, and we will swap them 1 with 2. So he would be 8, and he will be 1. Secondly, we will also what we will do, we will also check 1 with 5. Like we are shifting down until it's equal or more than the elements that we are checking. So here we also uh, swap 1 with 5. 1 and the 5. So here, as you can see, it's in its order place. It's like sorted. So we shift it down. However, it takes some time, log n. As you can see, it's like binary. So we only consider logarithmic n time. And as we said earlier, the time complexity of our coding of our algorithm would be n. It's to we use it to heapify it, and the second one we log n. We use it to pop the largest element, like as we showed it. It was 9, and we will pop it k times, yeah, to find the k's largest element. So time complexity of it would be n plus k logarithmic n.
So let's go into the coding part. Firstly, what we need to do, we need to create a priority queue, priority queue, and we will use an integer as a parameter, and the initialize new priority queue. So here, also what we need to do, we need to make sure that is it a min heap or it's a max heap. In this case, as we in this given description, we need to find the case largest element. It would be easier to use a max heap in here. As we know, by default, the priority queue would make it as a min heap. So we need to make it as a max heap. We can use this collections collections reverse order method to make it a max heap. And this is our heap is max heap. Secondly, what we need to do, we need to add all elements into our heap. Let's say q add n. So we already added all of our elements in our heap, and here we need to initialize answer sheet and I. Why we need this, and this is why we need this because we here we need to make sure that it's in the case element. Yeah, it's a second case element or it's the source case element. So we will pull the elements in each iteration. So if our here, if our I is equal to k, in this situation, we'll make our ends into the p whole and the return it as answer. And here we need to multiply it in each iteration until the nums of length. Yeah. If our I is not equal to the t, we will just fold it in each iteration. Otherwise, if like there is no k elements in the array, we will just return 0 in our. So let's start. Let's test it. Is it correct or not? Yeah, it's accepted. And then let's submit. So as you can see, it's submitted. And here, why this is a more efficient way than using a sorting algorithms? Yeah, there are some or more methods for solving these methods. However, by using data structures, it's easy and more convenient us to learn and use it. So that's why we use this method. Also, the time complexity of it would be more efficient than other algorithms. So, hope you enjoyed this video. Have, subscribe and like my videos. So, thank you very much. Have a nice day.